In this lesson, we're going to take a look at circuit diagrams and resistors and how to measure voltage and current in a circuit. So we're starting this unit on DC circuits, which means we're going to have direct current. We're not going to alternate current. And so the symbol diagram for a DC circuit is these alternating long and short parallel lines. This is the symbol for a battery, and the longer line represents the positive terminal of the battery, the shorter line represents the negative terminal of the battery. Long lines like that represent wires. A zigzag squiggle like that represents a resistor. Now, a resistor's job is to convert electrical energy into heat. And that means we're going to have power ratings for these, how quickly they can do that, how much energy they can change. But essentially, since this thing is providing a voltage or a difference in potential energy across these terminals, and a wire is a perfect conductor, it doesn't change how much potential energy is here. This thing can. It's a load. It reduces how much electrical energy is in this circuit, which means voltage drops across this. So across this, if we have 10 volts, on the other side of this we'll have less than that. And then we'll measure that with a voltage meter. I'll show you how we hook that up in a minute. Light bulb's kind of a squiggle that's encased. That's a light bulb. And it's exactly what it sounds like. It converts electrical energy into light. You might see a diode. A diode is a triangle with a bar, and it's a one-way gate, so it only allows current to flow in one direction. A light-emitting diode is still a diode, but it also emits light. So if it's got arrows on it, that's a light-emitting diode, and that's given the symbol, or the LED, for its light-emitting diode. And then a switch, which has a node and a gate and another node, so that can open or close to let current flow or not. And that's probably enough for now. You might see a capacitor, which is two long parallel lines, and it actually represents the two plates in a capacitor that are separated by an insulator. And what can happen is charge can build up on these two plates, which is a separation of charge, which is going to create a potential difference, so we get a voltage across those. But in a DC circuit, that is actually a break in the circuit, so current can only flow until the voltage in here matches the voltage across the battery, and then there's no potential difference and current stops flowing. Okay, so that's a capacitor. And we might spend some time learning about those with DC circuits. We'll definitely get into them with AC circuits. So that's a capacitor. Now, this resistor, I said they come in different values and they have different power ratings and they can do different things. Resistance is measured in ohms, and that has the symbol of that thing. Upside down horseshoe looking thing. And there's a color code that shows what the resistance actually is. So a resistor actually sort of looks like this. And this could be brown or gray or black or whatever. And on one side it has a silver or gold color band, and that's our tolerance color band. So how close its value is to what we hope it is. Tolerance, spelled that wrong. And you're going to see gold or silver, so whatever, this is whatever, the plus or minus however much percent, the resistance from the stamped resistance. And then we have three color bands, 1, 2, 3. And these color bands represent different things. They're numbers, number, and multiplier. So what I mean by that, when I say number, multiplier, is they're given to us in scientific notation. So we might have 4, 3 times 10 to the 5th or whatever. So this multiplier is the power of 10, and these two numbers are actually the digits that make up these first two. And sometimes you get a fourth band on a resistor, which means it follows the same convention. The first three are the numbers and the last one is the multiplier. So how do I know what color band represents what number? Well, the color code goes like this. And each one of these colors represents the digits 0 through 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I had a resistor that it had, say, this color was red, and this color was orange, and this color was yellow, what that would mean is the resistance of this resistor is red, which is 2, and then orange, which is 3, times 10 to the power of yellow, and yellow is 4, 23 times 10 to the 4th ohms. Okay? That's the resistance of a resistor that has red, orange, yellow color bands. Now, you can also measure the actual resistance of that resistor with an ohm meter. You just hook a lead from here to here and it'll tell you, hey, this is how many ohms we have. And as long as our tolerance is fairly close, the stamped value and the measured value should be fairly close. They're usually just a few ohms off. And usually the stamped value is close enough to do the calculations with. So an ohm meter clamped here and here will tell us resistance, but what if we want to measure how much voltage is in this circuit, or we want to measure how much current is flowing through it? Well, we should define those. We know what voltage is, but current is rate of flow of charge. And it turns out it's measured in amps, and 1 amp is 1 coulomb per second. Okay? It's actually quite a lot of charge. We'll probably deal in milliamps, so thousandths of an amp. To hook up a voltage sensor is pretty easy. You just, whatever you want to measure the voltage drop across, you put one lead here and one lead here, and then that hooks in to a voltage meter. And that'll tell you the voltage drop across the resistor. You could put one lead here and one lead here, and that would tell you the voltage produced by this battery. A light bulb will have a different voltage drop. But voltage is easy to measure. You just put your 2 leads on either side of your component that you're interested in. Current is a little bit harder, because current actually is the flow of charge, and to measure that we actually need the charge to flow through the ammeter. And so what we actually have to do to measure the current is break the circuit apart and put the ammeter in there. So what we would do is we would break this wire and we would feed it into our ammeter, and then we would take the other wire and put it back in there. And that would tell us the current leaving the battery. And then if we wanted to know the current coming out of this resistor, we could do the same thing. We'd break the circuit and we'd put our ammeter in here, right? And we could see the current that came out of this resistor and is entering our light bulb. So the current might be different in different places in a circuit. It's not in a series circuit like this. Voltage will be different across different places. But we can measure the current by breaking the circuit and putting our ammeter in there to close the gap. We measure voltage by putting our leads on either side of the component we're interested in.